All right, we'll get started. When people join, they'll join. Appreciate everybody taking the time. I'm Carl Richter, hosting the presentation today. The focus is going to be on sustainable manufacturing. Target's going to be about 30 minutes. We're going to be recording it. We'll put it on our website in a week or so. Use the chat or the questions, and we'll try to get those answered at the end of the presentation. Everybody's muted at the moment. So again, the focus is going to be on sustainable manufacturing. There's some fluid power statistics sprinkled throughout the presentation here and there. We'll talk about ESG scores, about the long-term risk for a company. We'll do a deep dive into tangible real cost on hydraulic systems. This isn't bashing hydraulic systems by any stretch of the imagination. It's just present, hey, these are real costs. These are the pros and cons, and try to educate people on help the decision makers make the proper decision. We'll talk about some potential energy savings as well as a little bit on the SHA, but for the most part, it's going to be wrapped around the sustainable manufacturing and fluid power. So fluid power statistics, it's fluid power technology is proven. It's a mature technology. It's been around for a long time. There hasn't been any major developments and advancements recently. It's a workhorse across the United States economy, world economy to some degree. The $24 billion fluid component industry. It employs about 1 million people just in the U.S. alone. So it's going to be around. It's a powerful industry, and it's going to keep on cranking. It's not going to be rising like the old days, but it's going to be around. That's the macro side. Again, staying on the macro, this is an interesting statistic. 1 to 2%. In fact, I saw a study saying 3% of all U.S. energy is used on hydraulic systems. That's a lot. So around 105 quadrillion BTUs of energy is used in the United States. So as I mentioned, 1 to 3% is consumed by hydraulic systems. We're going conservative around the 1%. That 1% equates to around $30 billion of energy being used for hydraulics, which is considerable. And this is in the United States. So on average, hydraulic systems are around 22% efficient. So that's about a $20 billion waste of energy. And the point of this slide is just a small increase in efficiency equates to billions of dollars and money to the factory. So that's the low-hanging fruit we're going to be talking about today. So ESG scores. ESG stands for environmental, social, and governance. ESG rating measures a company's exposure to long-term risks. It's basically the consulting firms. There's a bunch of them popping up here and there. You may or may not have heard of the ESG scores, but it's becoming more and more popular, especially in some industries like oil and gas, etc. So they create this matrix of risks, and some lending firms, they base financing on ESG scores. Again, environment, social, governance, climate, under environment, natural capital, pollution and waste, environmental opportunities. In the social world, there's various categories that people are doing a deeper dive in. On the governance, it has to do with the corporate entities. And for this presentation, we're just going to kind of focus on the environment and how to reduce that score and your footprint there. So looking a little bit micro, in regards to some more fluid power statistics. 1 drop per second is about 400 gallons per year. At $30 per gallon, that's about a $12,000 cost to the business. The next bullet's an interesting bullet. It's a hydraulic fluid index. This was a study done by, I think, Mobile Chemical. In the United States, They estimate it being about a 4-to-1 ratio. What does that mean? It means if your factory requires about 100 gallons of fluid for the various HPUs and cylinders and hoses, that the factory would purchase in a year about 400 gallons. So about 300 gallons are being wasted in some sort of manner. 100 million gallons are lost every year in North America. That's about a 40-acre lake. Of course, there's environmental potential issues going groundwater, rivers, lakes, wildlife, etc. We can all appreciate that. Hydraulic fluid should be changed every 6 months or so, and there's costs associated with disposing that fluid as well. This is just an interesting number. $78 billion annual market is a global fluid market. That's huge. So what is sustainable manufacturing? We've heard it. Some companies take it a little more serious than the other. The bottom line, if you really look at sustainable manufacturing, there's costs that are associated with there, and there's cost savings that is available to you. And that's kind of what we're going to be looking at here. Sustainability means meeting our own needs today without compromising the ability of future generations to meet their own needs. It's a simple statement, makes sense. 5 key factors, plant focused is, again, on the micro level, environmental, elimination of waste and pollution, reduce energy, save time and money, and also that human factor. And so keep those in mind as we go through the presentation. This is a good summary from our wonderful government's website, Sustainable Manufacturing from the EPA. A large and growing number of manufacturers are realizing a substantial financial and environmental benefits. That's kind of a key point. That's the point of this presentation of that, is that there's financial benefits when you really review the numbers out here and you do a deep dive in there. Sustainable manufacturing is the creation of manufactured products like the Kyntronics SHA through economically sound processes that minimize negative environmental impacts while conserving energy and natural resources. Again, the SHA conserves energy. Sustainable manufacture also enhances employee, community, and product safety. So it reduces the noise component as well as the slipping and falling component with the hydraulic fluid leaks. So more statistics. A study showed that every day in North America, a machine operator or technician falls on remnants of leaking hydraulic system. There's costs associated with that, with lost wages, downtime, the personnel, medical costs, all those sort of things. The second bullet's an important one. So 80% of hydraulic machine and equipment stoppages. Everybody, I think, that are familiar with hydraulics understand the contamination issue. So 80% of stoppages on hydraulic machines are due to contaminated lubricants in general. That's a $10 billion loss per year in downtime, which is considerable. With the SHA, as a note, there's no no downtime associated with our product regarding contaminated fluids. Ours is a closed system. It goes through a lot of care when we're filling, making sure it's filtered properly, no air, and all those air and etc. contributes to that contamination. $4,000 to $6,000 per minute. That varies from plant to plant, of course, product to product, but there's a dollar number associated with downtime and with that contaminated liquid. HPU hydraulic power unit intangibles. So the cost of hydraulic power units, even from all kinds of different perspectives, OEM, end user, etc. From an OEM's perspective, when they're building new machines, there's an engineering design component. They got to figure out the hoses, the size of the hoses, lengths, how you're going to connect the hoses up, how you're going to mount the hoses, brackets, installation, maintenance, on that equipment, a continuously running motor. There's also floor space. In some machines, they like to be mobile. You got to have the HPU to be mobile as well. Of course, the downtime component we already talked about. And then you have the environmental cleanup, disposal, costs. All these are words. We're going to try to put some costs associated with all this. I'm going to spend a little bit of time on this particular slide, doing a little deep dives. So there's 5 categories: environmental, energy, time and space, the human factor, as well as machine downtime and the product quality. So the first section, it assumes a 200 gallon per year need for HPUs in the plant. So assuming the 4-to-1 hydraulic factor index, and this is yearly costs. So the plant would have to purchase 800 gallons of fluid based on the HFI 4-to-1 index, which means there's a considerable amount of fluid that is going away. So we assume also 2x is lost. And that's the 400 gallons. So 400 times the 20 gallons, $20 per gallon is your $8,000, and that's $30 per gallon times 800 is $24,000. I know this is a lot of numbers, but basically with the HFI index, assuming there's 2.5 that is going to disposal and 2 times going to just waste, ground, clothes, shoes, rags, buckets. These are your real numbers of hydraulic fluid. Power on demand. Again, we're just trying to put some numbers together for the decision makers out there. Power on demand is a big factor. So this particular example assumes one 30 horsepower continuously running hydraulic power unit. That's run about on average 22% efficient, 30% duty cycle requirements. That's for the SHA. So if you just kind of compare, you have a 10 times more costly component with the HPU itself in this example. Again, power on demand means the SHA only runs when it's needed to run and doesn't waste energy when it's in between cycles or running unloaded. Time and space. Again, there's every plant has space requirements, and some plants this means more than others, which is the space of the HPU and space it takes up, type of thing. There's space requirements. Again, we're trying to be conservative and just went with that number, $2,000. Maintenance time. We also put a component of maintenance for the SHA, blowing out the fans or just inspecting. Be realistic compared to obviously there's more maintenance associated with HPU and more costs associated with that. And you got the human factor, being that leaky oil and the slippery surfaces and the noise situation and all those sort of things. There's a cost associated with that. The last category, which is an important category, we've all been there regarding people standing over your head, hurry up, get this thing running. So there's a cost associated with downtime, and you like to try to minimize downtime. So with contaminated fluid, the SHA does not have any risk of contaminated fluid and downtime associated with that. Again, these are just numbers, but there are costs associated with that, and we just wanted to make sure that there's a category for that. Quality and scrap. Of course, with the SHA, it's a very precision device, servo controlled. You can have better quality, less scrap. So overall, you can debate these numbers up or down, but there's a significant advantage with the SHA product and just looking at the hydraulics. So some energy reduction techniques and options. Of course, the regular maintenance, making sure you're reducing the drops, higher quality hoses and connections, possibly an auto timer on the HPU itself when it's not in use. Digitally controlled valving to help on quality product, etc. Induction motors, drives on the HPUs. And you get into the servo power units, get into power demand section. So servo power units only run when they're needed to run, so you get the savings there. Lesser risk for leaks. Go down the road of electromechanical actuators that are also out there as a power on demand solution. And obviously the Kyntronics SHA power on demand solution as well. So I wanted to kind of do a little analysis on the EMA electromechanical actuators and the benefits of those, as well as the benefits of hydraulic. There's a lot of benefits regarding the hydraulics. It's robust, high force density, the fluid characteristics, virtually incompressible, which leads to the shock load. Hydraulics have no issues with shock loads. Ingress protection is also a nice advantage with hydraulics, and the plant environments is always a challenge. EMAs, easy control, 4-quadrant control, they're easily configured. The software as well as hardware, you can add, delete cylinders, actuators as needed. Power on demand is a big factor there. Field bus connectivity, diagnostics, all those sort of things. So the EMAs, they don't like the ingress protections. There's a challenge there. Metal wear, load dependent. The higher the loads, more likely the EMAs will fail. Shock loading is a major issue. So EMAs have been focused on hydraulics for a while. And just a quick example, one OEM we've been working with recently, they went down the road, large OEM went down the road of replacing hydraulics, air oil, etc. They went down the road of an EMA manufacturer, did all kinds of tests at their plant in a nice environment. The EMAs are a little fragile. And in this environment, they ran thousands of cycles. They're all excited about it. They went out and distributed this product into the field in production and experienced real life shock loading. As I mentioned, the EMAs are a little fragile regarding special shock loading, and they just started failing left and right. So there was a lot of money spent from the OEM on these EMAs, replacing them, and they stopped using the EMAs, and they're going back to hydraulics, and they're reviewing our product as well. So again, this a note of the fragility of EMAs, especially around shocks. So there's challenges with EMAs, and there's also challenges with hydraulics. Of course, you got the leaks we talked about around continuously running motor, difficult to control sometimes. And you got those violent control transitions when you're switching solenoids back and forth, that leads to leaks, of course, the noise and floor space and maintenance. So what if? What if you can combine both of the benefits of both those technologies? EMA benefits along with the hydraulic benefits in one product. That'd be a pretty special product. On top of that, you're eliminating the challenges of both of those proven technologies. So with our product, that's the SHA, you don't have any metal wear, you don't have any leaks, virtually no maintenance, ingress protections, powerful, all the benefits again of EMA and the hydraulics. A little bit of a deeper dive into the product itself, the SHA. I know a lot of you are familiar with it. Some may not be, but basically it's just a servo motor connected up to a gear pump. Rotate it one way, you push the cylinder up. Rotate it the other way, it pushes the cylinder down. Not a lot of components inside here. It's a powerful product. You can parallel these up as needed, up to 42-ton capability. Again, you can parallel up, so the tonnage can get significant. The advantage of the hydraulic fluid characteristics, again, nice advantage with that is you can orientate and configure the actuator in all kind of different orientations for the machine to fit into the machine. We've done all these and many others. EMAs, you just can't do that with the gears because everything's connected up physically. So nice advantage, again, product-wise, fit into the machines. Servo power units. This is something we're selling today. So there's some applications that the customer wants to make sure they maintain their existing cylinder for whatever reason, fit, they're used to it, it's proven, and you want to either remove the HPU or get better control or down that road. So we also provide the servo power unit. It can be an all-in-one, or it could be just a servo power unit with the customer putting on their motor and drive and doing that themselves as well. So servo power units are also available as a solution for the sustainable manufacturing. All-in-one solution. You've heard this before, a lot of you that are familiar with us. So we promote the all-in-one to try to eliminate the finger pointing. We do all the testing in-house, sizing things up. We have partners out there also, Rockwell as well as Siemens and others that do the all-in-one themselves as well for the customer. So the Rockwell, a lot of you know, we have the AOI and the Siemens. We're working on things with them as well. So the all-in-one again is an approach that's unique with Kyntronics. Again, trying to avoid the finger pointing, just so we just don't like providing just an actuator and walk away. So we're going to provide the whole solution that we can do to get the whole thing working for you, regardless of the installation.
Hey, Carl, forgive me for jumping in. I'm just going to point out the obvious, hopefully, and that is that any motor and drive can be used with our actuators. So you always have that option available with your accounts. And we just like to remind you that we're not a Rockwell or a Siemens value-added reseller. So they would source those drives and motors independent of us. We'll certainly assist them with the configuration and whatever they need. And in the case of the Rockwell, we do have this add-on instruction, but I just want to make that clarification. Thanks.
Thank you, Mike. So this is just a recap of some. This is from Mobile Chemical on lost, 1 drop in 10 seconds, how many gallons per year that is. That's about 40 gallons per year, 5 seconds anyway. So when the drops per second, the quantity of drops per second, these are all dollars going out the door. And then, of course, environmental issues going with that, disposal and all those sort of things, and safety. So this is a considerable amount, depending on the amount of HPUs, et cetera, that are going on in the plant. Sustainable manufacturing from the SHA's point of view. So reviewing those 5 key factors that I mentioned earlier. So environmental. So how's the SHA apply to that? So again, it's no leaks, uses a minimal amount of fluid. Down here at 10,000 pound force actuator, 8-inch stroke, the cylinder is only about 14 ounces of fluid compared to a lot with an HPU and a lot with a gearbox. Eliminate waste and pollution, eliminates the need to continuously replenish the hydraulic fluid, so you don't have to replenish it. Once we ship the actuator, there's no need to replenish the fluid. It's in there for the life of the actuator. So no disposal, no purchasing hydraulic fluid yearly, etc. Recover and reduce energy. We talked about the power on demand. It only runs when it's needed to run, so you have a definitive yearly savings with the SHA versus the hydraulic world. Saving the time and money, reducing the downtime, contamination of the fluid, saves on design and installation time. We do a lot of that up front. Take the actuator out of the box, connect up the wires. Software's there, it's proven, ready to go. Less maintenance, of course. Easy to install and set up, as I mentioned. And you can reconfigure as needed. If you want position control today and force control tomorrow, you can easily do that. as well as the human factor. So safety, no slippery oil surfaces, so you don't have the human contamination or the cleaning up of the hydraulics, as well as the factory's noise levels are significantly reduced. So Kyntronics and our partners, we've done a lot of replacing of hydraulic systems, OEMs. Some plants are going down that road saying, hey, I want to go electric. So, you know, in summary, hydraulics are not going away. There's some places, some opportunities where you can use electric, SHA, as well as some of the EMAs. A lot of the hydraulics out there are just the way it is, 150 horsepower HPU. It needs to run fast or power. It is what it is, and it's going to stay that way. But we've been very successful replacing hydraulics on a lot of equipment end users as well as OEMs with this combined technology that combines the benefits of those two proven technologies, EMA and hydraulics, as well as eliminating their challenges. So the SHA, improving your uptime, environmental footprint, improves quality, efficiency, as well as the safety. That's the presentation.
Very good.
Where are we at with these questions?
Yeah, just as a reminder, everyone, we've got you muted, but there's a chat box available on the right, and there's also a question box. You can use either one if you want to type something in. And while we're waiting on some questions, I just want to mention that we've given you some pretty high-level bullets here that you can use to address even your clients at the senior most level, right? This being able to help them impact and raise their ESG score, which will help with their loan rates, for example, not to mention the goodwill that is being measured by people like KPMG and others out there that is also likely to impact their share price. All those high-level things you can actually address with this technology. And of course, we understand, and I'm sure you've already had the opportunity to experience that you're doing a lot of missionary work out there, introducing and educating your customer base on the merits of this totally sealed, compact, all-in-one solution and how different it is from your traditional hydraulics. And as Carl just pointed out, how much more robust it is as a linear actuator solution over the alternatives that customers have been trying and oftentimes realizing the limitations of. When we talk about EMA, of course, we're primarily talking about screws, whether those are Acme screws, ball screws, roller screws, inverted roller screws. All of those have the same inherent Achilles heel or disadvantage, and that is if you put those on a press application, there is an impact load that is likely going to jam that nut over time. When you hit the same threads time after time at the exact same point on that screw, no matter how well you keep it lubricated, it's going to wear. We know this firsthand because we make thousands of these screw-based designs, primarily for a niche industry in the transportation market space, aerospace seats, and that kind of stuff. But we live that and breathe that ourselves. That's why we came up with this design. I don't see any questions popping up unless I'm missing something. And Carl, it's up to you whether you want to unmute folks and let them pipe in. But
yeah, everybody's unmuted. They have control of what they want. So if there's any questions, fine. If not, we can move on, and you can contact your RSM for any copies of this or download it once we have it on the website. And again, we appreciate your time.
Absolutely. Thanks very much. Look forward to helping you out however we can.
Yeah, I did post a question. Not sure you're seeing it.
I am not. I don't know why.
Yeah, the question was, what's the minimum and maximum power capacities for the existing SHAs? So in other words, like, you know, what's the power ranges or size ranges that you have now?
So it goes from, let's just say 0 to 85,000 pound force is our standard. Then you can parallel them up. Obviously, if you're down in the really low range, we're not as competitive as others out there. Our smallest cylinder is a 1-inch cylinder that can do 2,500 pound force. The capability of that at 3,000 psi.
Okay, here we go.
Does that answer your question?
Yeah, I think so. One follow-up. So speed is a concern of mine. I know it's going to be dependent on size and whatnot, but I guess the question is, do you have strategies to increase the speed on the different SHAs versus what might be like a standard speed?
Yes, that was a good question. We didn't get into any of that, but there's multiple ways to increase speeds. We have what we call a high-speed, high-force design that has a 2-cylinder approach, a high-speed cylinder, and it pulls the high-force cylinder, and it switches back and forth. So we've sold several of those out there. Then we have a multiple pump approach. So, and these are all based on if you want to go fast under no load and then switch over to slow at a high force load, you have that capability with this. So we have both those modes.
Yeah, so please don't be bashful. Get us your specs and we'll tell you whether it's in our sweet spot or it's not. And I do now finally see some additional questions here. One of which, Carl, is if the average HPU is 22% efficient, how does that compare to the SHA? And in our case, we're typically over 70% by the time we put the amps into the motor and put force out of the rod end. So we have very little inefficiency in our overall design inside of our pump and from the servo motor and the drive itself. But then even more importantly, just to remember, we only energize that motor when motion is required. Most of your traditional HPU systems, the motor runs continuously to keep that fluid flow and pressurized so that the force is available when they need the motion. Some of them have added VFDs. Some of them are adding servo motors that we have, which is a very high efficiency, your most efficient motor design technology. But that makes a huge delta in terms of the difference between what the traditional HPU provides versus what the SHA has as its normal operating criteria. And Carl, anything to add to that?
No, that summarizes it. It just as a note that 70% efficient. Some EMAs claim high efficiencies. Just have to peel the onion back on that. There's not. When you really look
By
at
the time you put the linear guides and the bushings and the bearings and everything else, your total transmission translates into something about 50% efficient. So just because they're advertising that the roller screw itself might have 90+% efficiency, by the time you give the equivalent linear actuator solution is what the SHA provides, their efficiency is likely to drop below ours. So we love to do all that educating, and we got slides in our deck to help you with that as well. And then another question is, what is the maintenance required with the SHA? You heard Carl mention that it's virtually maintenance free because it's a totally sealed design, so we don't have to worry about replenishing your fluid. There's no filters because we pressurize the system at the factory, removing all the air. There's no contaminants that are going to be drawn past our rod seal, but that is our single point of wear and the only what you'd call serviceable item on our design is that rod seal. And of course, we use a very high wear resistant material. It's called Viton. We can send you the specs on that. It's rated for a typical 50 million inches, and that's a very conservative rating. It's an easy calculation for you to make. If you have a 10-inch stroke, you go 10 out, 10 back, that's 20 inches. Divide that by 50 million. That tells you what your interval is that you're likely going to require replacing that rod seal. We provide that in a threaded cartridge design, so it's field serviceable, or you can send it back to us. We'll replace it for you. We'll give you an extended warranty on the unit. So yeah, we make that very easy. And I have the instructions that I'll gladly forward out, or your regional manager contacts can send you the procedure document for changing out that rod seal. But that's basically it. Anything else, Carl, that you want to add?
Good summary, Mike. That's about it.
Okay. And then we talked about the minimum maximum capacities, the fact that we go up to a standard 6-inch cylinder right now that gives you 85,000 pound force, and that we can synchronize those so we can parallel them up. And we've quoted 300-ton presses using 4 of our actuators, and we've been very competitive because if they need that servo control to change the speeds and or control the force during the stroke, which many of your complex forming applications now require, we've got a very cost-effective solution even up to those sorts of ratings. And I think that's it for the questions. Anybody else? I think that covers us.
All right. Well, again, thank you. And if you have any other questions that come up, feel free to contact your RSM or myself, or let us know how we can help you out. Appreciate you guys' time. Thank you.
Thank you.